All right, so the biggest thing I think I've gotten as far as feedback from students as far as remembering what to do is that when you root something, to undo rooting it is squaring it. And this is still your inverse game, just like basic equations from back in the day. So you're just undoing all the things. And we just haven't dealt with roots a whole lot. So in this case, what you also have to decide is what's underneath the root versus what's outside of the root. Super basic though, if it's all underneath the root, your first step is to get rid of the square root bar. And to undo square rooting something, that inverse operation is squaring it, and you're going to square both sides, which in this case makes the root bar go away and that squared go away. So it's going to be m minus 1, and then 1 squared, which is 1 times 1. So we still just have 1. And again, this one's super basic easy. So then you're going to add 1 to both sides, because again, you're just trying to solve an equation. So m equals 2. And of course, as always, like every time you've ever solved an equation, you can plug that in. So 2 minus 1 underneath the root bar is 1. And the square root of a positive 1 is indeed 1. So we know we did that one right. Number 2 is the same thing, just different numbers. So I'm going to skip that one, and we'll come back if we have more time, just because you have one of those. And then I'm going to go down to number 3. So still the same idea. This is even easier because there's nothing going on underneath that root bar, except we just need to get rid of the root bar. And anytime you square root something, you're going to square it. And by squaring it, that gets rid of the root bar and the 2 on the side where our variable is. So b is going to equal to 4 squared. And 4 times 4 is 16. So the square root of 16, does it equal 4? Indeed, the square root of 16 is 4. So we did that one right as well. Number 4 is just amping it up just a hair because there is a variable, but just to see all the examples and types of way they can do these basic guys and not to panic because there's a variable there. So squaring to get rid of the square root bar. So we have 25v equals 5 squared, which is 5 times 5. It's going to give us 25. We need to get v by itself. So that's 25 times v. So we're going to divide by 25. And in this case, v is going to indeed equal 1. And again, you can check it no matter how big and crazy they get. 25 times 1 is just going to be the square root of 25. And the square root of 25 is indeed 5. So we did that one right. Again, staying super basic. After those 4, we're going to get a little more furry and fuzzy. Number 5. So there is a radical on both sides. So there's a square root bar on both sides. Same principle though. We're just trying to get rid of them. If anything, as ugly as it may seem, it's really pretty nice because once you square both sides, it doesn't actually square anything in this case. It just gets rid of the root bars. So that square root and that square, and that square root and that square. So you end up with 2r minus 60 equals r over 8. And then we just need to solve for r. The first thing I would do is get 8 off the bottom. And I wouldn't move my 60 yet because then you're going to have more fractions. So I'm going to multiply by 8 because that is r divided by 8. And both sides by 8. And then you have to distribute that through, which is going to give me 16r. And then 8 times that negative 60. Positive times a negative gives me a negative 480 equals r. Again, just like old school math 1 kind of problems, we have to get our r's together. So I'm going to move my 16r, but when I say do that, if you do it in a different order, that's fine. You just need variable on one side, whole number on the other side. But you do want to make sure you understand that 480 is negative. That minus in the front, don't lose it. Because sometimes when you leave it out to the front, it gets lost and people lose it and forget to write it down, or they just leave it there. So if I have a positive 1r and a negative 16r, that gives me a negative 15r, because that's 1 minus 16 is 15. And that is negative 15 times r. So we're going to divide by negative 15. And that's going to give us a positive 32. So again, we could plug that in if we wanted. So 2 times 32 minus 60, and we're going to take the square root of that. should equal to the same thing as 32 divided by 8 and take that square root. So 2 times 32 should be 64 minus 60, which gives us the square root of 4, which should give us 2. Can work down the other side. 32 divided by 8 is also going to be the square root of 4, which also gives us 2. So we know we did that one right. Number 6, I hope, looks as simple as the ones above it, just a little different. We need to get rid of our root bar, so we're going to square this side. If we square that side, we have to square this side, which is going to end up giving us 25 equals root bar, and squaring is 11n plus 3. It just undoes the actual root itself. And then we need to get our n by itself, so we're going to subtract 3 from both sides. And that is 11 times n, so we're going to divide by 11. And n equals 2. Of course, at this point, if I were you, I would check it. So 5 equals 11 times 2 plus 3. So 5 equals the square root of 22 plus 3. And I'm just writing it all the way out so you see where everything came from and where everything is. So 5 equals the square root of 25. And indeed, the square root of 25 is 5. So we did that one correct as well. Am I going way too fast, or do you have any questions so far? I'm always on the fence whether it's better to just see them or you want me to go super slow. Okay, cool, awesome. All right. So again, number 7, it just has 2 root bars, but don't panic. Like I said, in my opinion, they're my favorite because they just undo each other. And we get down to some basic equations that just happen to have variables and whole numbers or constants on both sides. So x minus 9, 42 minus 2x. We get our x's to one side and our whole numbers to the other. I like to work towards the positive x, so I'm going to add 2x and move it this way. But as I've said before, it doesn't matter which way you choose as long as you have constants on one side and whole numbers on, constants and then variables on the other side. Because no matter which side you move it to, it'll come out in the wash with the same answer. So my work may not match your work perfectly, but our answers should be the same. And that's just a matter of holding on to your positive negatives appropriately and not losing them. So 3x equals 51. And that's 3 times x. So we're going to do 51 divided by 3 because that's the inverse of multiplication. So divide by 3 and x equals 17. So ideally, 17 minus 9 should be equal to 42 minus 2 times 17, and taking the root of that whole thing. 17 minus 9 is the square root of 6. Oh, the square root of 8. And then 2 times 17 is 34. So 42 minus 34 does give me the square root of 8. And you can finish that out if you wanted, but at this point you know they match. So you have gotten to the point where you can say, yes, I did that right. So the answer is indeed x equals 17. Because the square root of 8 is going to give you a decimal. Or if you were to simplify the radicals, I believe it's 2 times the square root of 4 would be the simplified mixed radical. Now, when you have a variable on the outside, this changes up a little bit. Now you start playing in quadratics because you still have to square both sides to get rid of the root bar or radical. So these go away. It's not everyone's favorite when they see an n or x squared. This is not going to be a constant in a whole number. Hopefully, we're getting to where when we see n squared or x squared or anything squared left over, quadratic is what you want to think. So then you would go GCF and then all your forms of factoring. But you know you have to factor. You could also use quadratic formula if you wanted to, if you're pretty good at plugging that in and you have it memorized. But that means I need to get it set equal to 0, so n squared minus 4n equals 0. It's not a trinomial, so you don't want to end up, you're not going to factor like by big star or ACB chart, I believe I've mentioned, is one of the things I know a lot of the Pinecrest teachers use. But as far as factoring as a whole, there's not a real consistent method among all teachers. So it's whatever has worked for you. And if things are not working for you, obviously holler and we'll come up with a way that will work for us. But you always want to check for a GCF first. And in this case, they both have an n. So I can pull an n out and then n minus 4 equals 0. So this is going to have multiple answers because I'm going to set both of these equal to 0. So n equals 0, n minus 4 equals 0, and then solve. So n minus 0 is just n minus 0. I'm going to add 4 to both sides, and n equals 4. Now you do want to make sure that this works, and so you want to check it. So if I plug in a 0, so 0 equals the square root of 4 times 0, which 0 is the square root of 0, because 0 times 0 is 0, and that's what square root is. It's asking what number can I multiply times itself to give me the number that's underneath that root bar, versus 4 equals the square root of 4 times 4, which is square root of 16, and hopefully we do know that that is 4. So both of these answers are viable choices. And the reason you want to check is because as we get further along, and even in Math 3 and forward, you are going to come up with equations where your answer makes it not a real algebraic, it'll break a rule. So then though algebraically with your inverse operations and solving, it does come up as an answer, it is not an answer to the question though. And I guess the example I always use is distance formula, because every time you take the square root of a number, you have a positive and a negative answer, but you don't use a negative in distance, so we never really discussed it. And I say that because I taught Math 1 a lot, and trying to get people in Math 3 and sometimes in Math 2 to remember there's two answers every time you take a root is a little bit of a battle because you spent so much time taking roots and using the answer that pertained to the question. So again, so checking is beneficial in just making sure that both of these answers are viable to the conversation or the problem at hand. Number 9. So again, super easy. Hopefully at this point you're seeing the pattern. We're going to square it to get rid of our root. Square it. So 6 times 6 is going to be 36 because that's what 6 squared means. That gets us rid of those. So it's going to equals 12x. That's 12 times x. So we're going to divide by 12. And we should get 3. And of course you can check it. So 6 equals the square root of 12 times 3. 12 times 3 is the square root of 36, which does indeed equal 6. So x is equal to 3 here. So we're good there. Number 10 is a little different in just that the minus is on the side with the x, and sometimes that stumps students a little bit. And I don't think it's that if you had someone walking you through it, it probably would not stump you, but when you're by yourself, you like to just ignore and drop negative bars or negative symbols. So we have to be really careful because that negative x makes a big difference. So we're squaring stuff. Root's gone, 2 is gone. 9 minus x equals 1 squared is 1. So that negative in front of the x, what I've asked a lot of students to do, if you know that you track yourself missing that a lot, like that is a place of oops, is put that 1 there. And then most of us have a little less apt to get rid of that altogether because there's a number there. Even though we know that it was assumed 1 anyway, we're going to subtract 9 from both sides because we get rid of that positive 9. Again, trying to get x by itself. That negative 1 is like negative 1 times x, so we're going to divide by negative 1. And x is going to give us 9. So the square root, ooh, where'd I mess up? Because that's not a thing. It's not going to work. Because 9 minus 9 is 0, which is not going to give us 1. One squared is 1. 9 minus 9. Ooh, found one. Or am I just having a blind moment and it's not making sense? And I need to write it all the way out. It should be 8. Oh, because 1 minus 9 is not negative 9. Negative 8. There we go. 8. 8. Perfect. Made my own little absolutely not hard math mistake. An oops mistake. So 8. So 9 minus 8 is equal to 1. And hopefully that showed you the benefit of doing the check part because silly errors happen. I think I just multiplied instead of actually subtracting them. So apologies. X equals 8. Number 11. So you're going to run into some of these that have things going on outside the root bar. When there's something going on the outside of the root bar, you can't just square both sides. So that rate, you want to get the square root by itself. So I'm going to move the 6 over. And now I'm going to square both sides. And this is where they get really Math 2-y versus, though you didn't do these in Math 1, the equation level of the prior ones have been very Math 1-y, if that's even a word. So get rid of the root bar, get rid of the 2. So I have 7n minus 54 equals. Now, because there's a minus in here, you are not distributing that 2. That actually means n minus 6 times n minus 6. So at this point, you're either going to FOIL distributive property if you want to think about it, and or box method, whatever works best for you. And Ava, thank you. Sorry, I now see that you typed in. So we're going to do n times n is n squared. N times a negative 6. Just get negative 6n. Negative 6 times n. Negative 6n. Negative 6 times negative 6 gives me a positive 36. And then we just have to clean up. Again, you're seeing that n squared, so hopefully already a little alarm's going off in your head, knowing that you're going to have to either factor by GCF or some form of solving a quadratic to get these answers. So if I clean this up and leave this over here as is, it's n squared minus 12n plus 36. Because you see that quadratic on the right-hand side, you want to move everything to one side. So I'm going to get everything on this side because n squared is positive over here. So that's a good thing. That means I don't have to factor out a -1 or do any kind of corrective factoring if I keep that n squared positive. So I'm going to subtract 7n. And I try to write it with who it goes with, because as you see, I can easily get distracted and mix up things. So negative 54 equals n squared minus 19n plus 36. We're going to add 54 to our 36, which is going to be n squared minus 19n, 40 plus 90. I'm going to grab another sheet of paper just in case we make it all the way down, working on all of them, so we don't run together. And so for n squared minus 19n plus 90, we're going to factor that bad boy out. So we need a set of these before it's said and done. So we're doing the factors of 90, the multiples of 90, that will add or subtract to give you 19. So 1 and 90 is no good. 2 and 45. 3 and 30. And I'm sure you already know that, or some of you already see that it's 9 and 10, but just trust me on the fact that it's worth it, especially from this point forward, since you do get a calculator and you do have time to make sure there's not a second one, because there's a couple combinations that there are more than one, depending on if this value is positive or negative, which one is actually going to be correct. And then 5, 18, and I think I showed you guys this, but if not, if you have a TI-84 or 3 anywhere, or an app on your phone, if you have a Droid app, it's called Wabbit, W-A-B-B-I-T, EMU, that turns your phone, if it's an Android or a Google phone, into a TI calculator of your choice. You can pick which one it looks like. But if you go to y equals, and I do 90 divided by x, and then hit second graph, all your whole numbers here are going to be your factors. So we see 4 gives us a 22.5, which means it's not a factor. So 5 and 18, 6 and 15, and then again down to 9 and 10. And we are trying for that 19. So that's going to be the only pair that would work, our 9 and 10. So it's going to be n, 9, and 10. The middle is negative, so your biggest, actually they both have to be negative, sorry. I get to a negative 19. Since it's negative, and they have to multiply together to give me a positive 90, and we know a negative and a negative gives us a positive. If you add those two negatives together, we still get that negative 19. Then we're going to check it, or we're solving it. So setting it equal to 0. So n equals positive 9, and n equals positive 10. So hopefully both of these are viable answers. So if we check it, 6 plus, I think I'm running out of space. The square root of 7n minus 54 equals n is the problem we're working on right now. So 6 plus 7 times 9 equals 9. And then 6 plus 7 times 10 minus 54 equals n. You could at this point also, if you wanted, because it's equal to n, you could type in, so it's kind of like it being equal to y, type in the 6 plus like just this portion into your y equals, and then go down and see where your x and your y value matches. And just to, because again, we know, most of you should know by now, if you're really good at staying the rope and getting everything right all the way through a problem, that's one thing. But if you know you make careless errors, or you want to double check your checking even, this is a way to do it. And so when we see 9 is 9, that's perfect, and 10 is 10 is 10. But then again, no matter what, the rest of them, 22 works, but it gives me an output of 16, not the output of the X value. As our problem said, whatever we plugged in here is what it's going to equal. So in your calculator alone, once you plug that first half in, because it is set equal to n, you should see them both pop up as the same. So our 9 and our 10 did work. They do exist, and there's no error message in your calculator, so you're good to go there. So our answer is indeed 9 and 10. This problem is going to work the exact same way. So this is kind of a little bit cheaty-ish, I guess. But if you're willing to watch it and you're willing to show up, I'm willing to show you. So 3 plus is getting around doing some of the math. 7 minus x minus 31. And sometimes the trial and error in using your calculator takes a little bit longer because you have to scroll around a bit. But sometimes you get lucky and it pops right up, like in that case. So we should know the answer should be 8, and it looks like 5 as well. It is going to be a quadratic function because you see that b there, so the answer will be probably more than likely 2 solutions, but maybe not, because remember, when you're solving a quadratic, the solutions are just discussing at this point in Math 2 and back in Math 1 where that graph touched the y-axis. So there could be none, 1, or 2 for quadratics, because remember, it's a parabola, that big U. But in this case, our answer would be 5 and 8. And again, this only works because it's equal to a variable, and the 2 variables just have to match. So it's sort of in a form equivalent to y equals in this case. And then we did one of these, and we did one of these. So I think I've covered all the ones I have printed. Hopefully that was a little bit of a good review. Again, hit me up in a text or an email if you have any questions about some more types.